Okay, so for the first 2 days this week, we're going to do something different than the last half of the week. So we're going to finish up conic sections. Last half of the week, we're going to look at solving systems of equations. You've definitely done that before in Algebra 2. What we're going to focus on after we kind of review a little bit of like substitution and elimination is we're going to get into equations with 3 variables, but we're going to solve them with a matrix. So it's kind of a more efficient, faster way of writing things down that rather than elimination and substitution. So we'll talk about that on Wednesday and Thursday. All right, but first we'll finish up conic sections. So we did the parabola. We're going to do the ellipse today and the hyperbola tomorrow. All right, so with conic sections, there's always kind of a lot of vocabulary up front, like different terms. Like with parabola, if you remember, we had all kinds of terms. We had vertex, focus, directrix, lattice distance. Some of those terms you're going to see again. You're not going to see lattice distance. That's not going to come up. But focus, you're going to see that term come up again today. We'll see what else comes up. But we're going to start out just by defining what an ellipse is. So every definition of a conic section starts out, it's a collection of points that, and it satisfies some condition. Okay, so collection of points in the plane, meaning it's a flat, two-dimensional shape. Okay, and just to summarize what we've done so far, a circle was a collection of points that are all equidistant from a center point. Very simple definition. Parabola was a little more complicated. It was a collection of points that were all equidistant from 2 things, a focus and a directrix. This is a collection of points that involves a sum. So what this says is that if you draw an ellipse and you pick a point anywhere on the perimeter of the ellipse, and you measure that distance to one special point, which I'll tell you what it is in a second, and you measure the distance to another special point, and you add those 2 distances up, it will always come out the same. Depending on the size of your ellipse. For a given size ellipse, it'll always come out the same. If you draw a bigger ellipse, well, it'll come out different for you, but you'll always get the same number on your bigger ellipse. Okay. So B and C are the 2 special points. When I say whose distance is from 2 fixed points, B and C are the fixed points. E is a point that can travel anywhere around the perimeter of the ellipse. So the way I have it set up right now, line segment EB is 13.95 centimeters. That number will change as I drag E. Segment EC, a little bit shorter, 3.35. That number will also change. But the sum of segment EB and the measure of segment EC in my particular ellipse always adds to 17.3. Right? No matter how I move it, sometime rounding it might be a little off. Oh no, no. You don't want to move the point. You only want to move. You don't want to move the line, just the point. Okay? And you can add those up, 10.55, 6.75, you'll get 17.3, no matter where you put it. And that's, if you wanted to actually draw an ellipse, that's how you could do it. If you took like 2 push pins, put them in a board, and then took a piece of string and stretched them tight around the push pins, and kept it tight as you pull it all the way around, that's how you get an ellipse. That's the idea. So, any questions on the definition? Those 2 distances always add up to the same number. What they really add up to isn't important. Just that they always add up to the same. So those 2 fixed points are called the foci. We saw this term before. In a parabola, we had a focus. Now we have foci. Okay, plural of focus. You don't say focuses. So those 2 points, B and C, in my picture are called the foci. When I draw an ellipse, I'll probably call it F1, F2. Focus 1, focus 2. All right. So as I go through some definitions, I'm gonna you're going to see the definitions kind of tie in with this picture. So I'm not going to describe everything you're seeing right now, but we will be as we go through it. This equation right here, this part should make sense. Okay. If you measure the distance from any point to F1 and measure the distance from that same point to F2 and add up the distances of the two dotted segments, it'll always come out to a constant. What constant? Depends on the size of the ellipse. Okay. And there's some other stuff here which I'll highlight as I go through some words. So if you draw a line right through the ellipse, kind of draw a line through the ellipse the long way, not the short way. It goes right through the foci. That's called the major axis. Okay? And the major axis has everything important right on it. F1 and F2, which are your foci, V1 and V2, which are something else we'll mention in a little bit. Does anyone have a guess what the V would stand for? This term came up with parabolas too.
Vertex.
Yeah, it's a vertex, and then we have two of them, so they're vertices. Okay, so the line that goes right through the foci, it also goes through the vertices, but we haven't said that yet. It's called your major axis. And if you find the midpoint of the segment that connects the foci, okay, it's all like this. If you use the midpoint formula with the coordinates of F1 and the coordinates of F2, that'll give you the center of the ellipse. That's one way to say it. Now, technically, if you drew in the segment from V1 to V2 and found the midpoint using the coordinates of V1 and V2, that's also the center. It's the same thing. Okay. The way our book defines it, the center is the midpoint of the segment that connects F1 and F2. And that would be right here. The center can be at the origin, which is where it'll be when we start, or we can shift it. Up, down, left, right. Now, if you draw a line through the center, but perpendicular to your major axis, that's your minor axis. Okay, the way I remember it is the major, I think of major, that's the long one. Minor, I think minor is less important. It's like shorter, smaller. So the minor axis always goes through the ellipse the short way. The major axis goes through the ellipse the long way. And there's really only two orientations for an ellipse. That's one. I kind of consider the major axis is going horizontal. Or, the second one would be if the ellipse was standing up tall. The major axis would be vertical. So there's only two ways to really draw an ellipse. That's different from a parabola. How many ways did we have to draw a parabola? We had 4. Okay, ellipses only have 2. Okay, so that's your minor axis. Now, if you look where your major axis intersects the ellipse, okay, where does the major axis hit the perimeter of the ellipse? Those are your vertices. V1, V2. That's where the major axis and the ellipse cross. There's no special name for where the minor axis and the ellipse cross. We'll talk a little bit more about that distance later on. But there is no special name for the point that I know. Okay, so I think that's most of the vocabulary for ellipses. You get your major and minor axis, ellipses, center, vertices, and then the definition itself. Any questions on any terms there? Okay, so kind of things we're going to do. Same stuff we did with parabolas. Okay, they're going to ask you to discuss. So they'll give you an equation, and they'll just say, describe it. Where are the vertices? Where are the foci? Is the major axis up and down? Is it left and right? Sometimes they might ask you to make a sketch. Let's see, they could ask you to do the reverse of that, give you a sketch and say, what's the equation, looking at the picture. But those are going to be kind of the two big things. They give you an equation and you describe it, or they describe it and you figure out the equation. And we're going to have formulas, and there's going to be a chart that you can use, and I'm going to do it the same way we did the chart for the test on parabolas. Okay, you'll be able to have access to the formula chart. Now, I said there's only really two ways you can draw an ellipse, so there's only two different equations. This is going to be the case where it's centered at the origin. Okay, so we're not shifting it yet. We will be, but not yet. The foci are going to be C units to the left and C units to the right of the center. Now, just from knowing that information, that's enough information to tell you which way the major axis is running. Which way is it running here? Yeah?
I just had a question about what that is. Maybe the number.
We're going to have three letters. We're going to have A, B's, and C's. So we're going to talk about what each one means in a minute. But which way do you think the major axis is running for this ellipse? Yep.
Horizontal?
It's got to be horizontal because the definition of the major axis, it's the line that contains the foci. Well, this point is left a certain amount of units. This point is right a certain amount of units. There's no up and down at all. They're both zero, which means major axis has to go horizontal. So saying that the major axis is the x-axis, it's kind of redundant, but it is. And the vertices are going to have to do with another letter. Those are going to have to do with A. So we're going to have three letters involved, A, B, and C. So A is going to have something to do with vertices. In this particular case, the vertices are going to be A units to the left and A units to the right of the origin. Now, they're not always going to be A units left and right of the origin. That's only because our center and origin are exactly the same. When the center is not the origin, I'll show you how we think about it. But I always think of the vertex as A units to the left and the right of the center. If you think of it that way, then you're good. Think of the focus as C units, left and right of the center. Don't think of it as the origin, even though you could in this case. That'll trip you up later on. Okay, and here's your equation. So it's x squared over a squared plus y squared over b squared equals 1. That's a big thing with what we're going to see a lot today and tomorrow. The equations have to equal 1. So if you ever get an equation that's not equal to 1, that's your first step. Make it equal to 1. It's also important that A is always bigger than B, which is always greater than 0. So A and B are never negative here. And A is always bigger than B. In fact, that's how you figure out which one is A and B. If you gave me two numbers, and you said one of them's A, one of them's B, I'm not going to tell you which one. I'd say, okay, well, whichever one is bigger, that's A. And whichever one is smaller, that's B. Now, C is another letter we're going to use, and it has to do with the foci, but this formula doesn't have C in it. So if you're just writing the equation of an ellipse, you don't need C. But sometimes you're going to need C to do some arithmetic to figure out one of these two letters. Okay, that's where C comes in. So like if I gave you A and I gave you C, you'd say, okay, well, I want to write the equation, but I need B. Well, there's a formula that relates A, B, and C. So as long as you know 2 out of 3 of the letters you're looking for, you can find the third letter. Okay, and the formula is C squared equals A squared minus B squared. It looks kind of like the Pythagorean theorem, but it has nothing to really do with that at all. Now, one thing I want to kind of point out. Major axis is horizontal. Look at this equation. The bigger letter is under, the bigger of the two blue things I circled, the bigger one is under which letter? Yeah? X, right? The bigger one is under X. Wherever you put A, that's going to control which way the major axis goes. If you put the bigger number under the X, the major axis is going to go in the X direction. If you put the bigger number under the Y, the major axis would go in the Y direction. So we're going to see, you don't have to write it yet, because we're going to do it later, But when we have the major axis going up and down, the only thing that's going to happen is A and B switch. So you look at where A is. If A is under Y, it goes up and down. If A is under X, it goes left and right. All right, so we get that. To graph an ellipse, sometimes that's helpful, not always. Because you could have an ellipse like this. Now it has no intercepts. So it's not always possible to find intercepts. But if you can, it is something that would be helpful when you're making a graph. And here's what you want to remember about A, B, and C. A, B, and C each tell you something. Okay? A is always the distance from the center to the vertex. Technically, you could think of it as the distance from the origin to the vertex right now, but I wouldn't write that. If you think of it like that, it's going to mess you up later. So A is the distance from the center to the vertex. B is the distance from the center to where we hit the minor axis. So I said earlier, there's no special name for that point, but B, well, I don't have my axes on that one. Let me just scroll back up. So if I drew an ellipse in right here, major axis, minor axis, that's B right there. It's the distance from the center to where we hit the minor axis. And C is the distance from the center to the focus. Okay, so that's what A, B, and C mean. You'll never be given all three of those in the same problem. You'll probably be given 2 out of 3, and then you're going to have to use C squared equals A squared minus B squared to figure out the third one. Any questions on what A, B, or C mean? Okay. So let's start out by trying to find an equation of the ellipse. So the center is at the origin, the focus is at 3, 0, and the vertex is at -4, 0. Now, to write the equation, I know I need A and B. The focus, what letter does that have something to do with? Focus gives you a hint about what letter? Yeah?
C.
Tells me something about C. Okay, so I'm not saying that it's written there, but the focus has something to do with C. What about the vertex? What does that have to do with? A. Okay, so the vertex has something to do with A. So I've got enough information to get A and C in this problem with that. They're not giving me B directly, but I need B. Okay, I got to get B to find the equation, but I can do that later. Let's just worry about figuring out A and C first. All right, A, distance from the center to the vertex. Now, if you need to, you can use the distance formula, but most of the time you can really just look at it. Just if you need to draw it, you can, but you can usually just look at it and tell. What's the distance between the center and the vertex here? Rob?
7.
Well, what did we say about, first, what's one kind of general thing about A and B? They're always what?
Positive.
They're always positive. A and B are always greater than 0, and A is always bigger than B. So we definitely want positive. And anyone else have another, take another shot at it? What's the distance from the center to the vertex?
4.
4. Right, the center is at the origin. The vertex is 4 units to the left. But it's still on the axis. It didn't go up and down. So distance from the center to the vertex, 4 units. So we got A. How about center to the focus? What's the distance there? About Gabe? Well, where's the center?
0, 0.
And where's the focus?
3, 0.
So if you plot those 2 points and you just counted the distance between them, because they're going to line up perfectly straight,
3 units.
it would be 3 units. So we've got 2 out of the 3 letters we need, but to get the equation, we need B. What's the formula that relates A, B, and C? Yep.
C squared equals A squared minus B squared.
So we got C squared equals A squared minus B squared. Okay, so we go to solve it. Bring 16 to the other side. We're going to get negative 7 equals negative B squared. So what does B come out to in this case? Yeah.
Square root of negative 7.
Well, if it did, that would be imaginary.
Oh,
If it was the square root of negative 7. How come it's not going to be the square root of negative 7? What's going to happen? Yeah?
the negatives cancel.
Yeah, the negatives are gone. Because if we got an imaginary distance, that would if you ever take the square root of a negative, then something has gone wrong. Okay, you should always get positive numbers here. So it's just going to be the square root of 7. If they want a decimal, you could change it. If you're going to graph it, it might be kind of handy to know what that is as a decimal. It's probably like 2.5, somewhere around there. But if we're going to graph it, we probably should find that. But they didn't really ask us to, so I'm not going to worry about it. Okay, so now we've got B. Now at this point, you'd normally have to decide, is this going to be the equation where the major axis goes left and right, or up and down? Well, this is the only equation I've really shown you so far. So it's going to be this one. Right? But if you did have to decide, graph the focus and the vertex and see how they line up. Do they line up horizontal or do they line up vertical? So if you weren't sure, okay, you've got a focus at 3, 0. Well, they didn't tell you, but where do you have another focus automatically? So, right?
I don't know. What was the question? I wasn't paying attention.
Where would you have another focus?
The same place, but on the negative
Mhm.
axis, so negative 3.
So negative 3, 0. So I can already tell things are lining up horizontal. Okay, I'm going to have a vertex at negative 4, 0. I'm going to have one at positive 4, 0. And maybe you've noticed the pattern here, but the foci are always inside the vertices. Always.
This is a dumb question because it's something we should know, but why is it if you minus 16 from 9, you get the negative number for the figure in OB?
If you minus 16
Because you
from
have to
9?
move the 16 over, so you have to
Yep.
minus it from both sides.
Yes.
So then it just be negative.
It would be, and then it would cancel out with the negative on the other side. Because you already have a negative on the right in front of the b squared, and then you get another negative on the left from what you just said. Okay, so any other questions on how we get A, B, or C? All right, so now that's the hard part, we just fill them in. So let's look at our equation. Okay. It's always x squared plus y squared equals 1. Okay, this part never changes. Okay, so we can definitely start with that. So x squared, y squared equals 1. Now you just decide where you put A and B. Well, everything lines up horizontal. It means you want your major axis horizontal. So put the bigger number under x. Okay. A is the bigger number. Square root of 7 is like 2 point something. It's definitely smaller than 4. Now remember, when you put them here, it's a squared, b squared. So what's a squared? What about Emma? 16. And what about Natalie, b squared? 7. And there is the equation of your ellipse. Now, if I wanted to graph that I've kind of already got it done right here if I'm doing it by hand. I've got the distance from the center to the vertices. So that tells me that in the length of my parabola. But I don't know yet, or what I didn't graph yet was the width. But that's what B tells me. The distance from the center to the minor axis. So the square root of 7 is 2.6. So it goes up 2.6, down 2.6, and there's a really rough sketch of your ellipse. Question on that? Mm-hmm. Now, if you wanted to graph that on the calculator, what would you have to do to type that in on a calculator? Yep. Yep. Get y by itself, which it's about 3 steps. If you want to get y by itself, you would start by subtracting the. I'm just going to call this 1/16 x squared. Okay. Because that's what it really is. And if I'm going to graph it on the calculator, that's how I would type it. So minus 1/16 x squared from the other side. So bring that over. Then the next thing you would have to do is bring the 7 over by multiplying by everything by 7. Right, so I'd have y squared equals, multiply both of these by 7. So 7 minus 7/16 x squared. And the last thing would be just take the square root. And remember, when you take the square root, how many answers we get? 2. So y equals the positive and the negative square root of 7 minus 7/16 x squared. So what basically we have to do is graph the ellipse as a top part and a bottom part. We can't graph the whole ellipse at the same time. So let's graph it and see if it looks like the endpoints are 4 units left and right and about 2.6 units up and down. If they're not, then we did something wrong. Yeah.
How did you know when you did that little sketch, the point that was up and down?
That I got from B, because B is the distance from the center to the minor axis. So B tells you up and down, and then the A tells you how long it is. All right, let's see. I haven't tried it, so let's see how this looks. 7 minus. Let's do it as 7/16 in parentheses x squared. Oops, x squared. Okay, so that should give me half of the ellipse. Let's see. Yep, looks good. Looks like it's going to be 4 units left and 4 units right, and it's about 2.6 units up, which is exactly what we wanted. And then to do the negative, I'm just going to kind of go like this. Negative vars. May or may not have ever showed you that. But all I have to do is graph the negative of y1. So instead of retyping that whole thing again, I'm just going to put in negative of y1. And there's the bottom half of your ellipse. And that's pretty much what it should look like.
Wait, can you do that again?
To do that, yeah. If you want to get one of your variables, like you've already typed something and you want to just do the negative of the whole thing without retyping it, you just go to vars, and then it's under y vars and function. And you can just pick. Like if you wanted to graph y1 and just say add 5 to it, now I could just do a +5 without having to type y1 all over in again and then put +5. Most of the time, you're not going to have to graph it on the calculator. Sometimes I just like to double check my sketch, since it's not really that hard to double check. Okay. Any questions on that equation? Let's look at this one. So this one they want us to discuss. So there's the equation. Discuss is usually going to mean to describe which way the major axis goes, where are the vertices, where are the foci, and where's the center. Now, to do all of that, you should always get A, B, and C first. Looking at my equation, I have enough information to directly get what 2 letters? Yep. Yep. I don't have enough information for C, but I can find C later. What's A going to be? Yeah?
5.
Yes, A is 5. How do we know that? Well, the bigger number is always A squared. The smaller one is always B squared. So, based on that, what's B? Yeah.
3.
B is 3. Now, I can't describe the foci unless I know C. So, can someone tell me what's my equation to get C? Yep.
C squared equals A squared times B squared, or C squared equals 25 minus 9.
Yep. So C squared equals 25 minus 9. 25 minus 9 is going to give me
16.
Yeah.
I'm really tired.
Yep, that's first day back. I'm sick. It's not fun. But C squared equals 16, and then C is going to be 4. Sometimes C comes out nice, sometimes it doesn't. But we got all nice numbers in this case. Okay, let's start with the center. Where's the center of that parabola, ellipse? Yeah? Yeah, it's 0, 0. It's the only kind we've studied. You'll know when it's not 0, 0, because you're going to see a plus or a minus with the x and the y. Okay, just like with the parabola. So center, 0, 0. All right. Let's do the vertex. It doesn't really matter which ones you do next. Okay, you've got to do the vertices and you got to do the foci. So it doesn't matter which one you do next. Actually, it'd be nice if you spelled it right. So vertices. What letter tells me where the vertices are? A. A is the distance from the center to the vertex. Now, technically, you'd have to figure out, well, is this left and right or up and down? We haven't done up and down yet. So everything is left and right for now. So we are 5 units left and right of the center. That's where your vertices are. What's the coordinate 5 units right of the center? Yep.
5, 0.
And 5 units left?
Negative 5, 0.
Yep. So what I usually do is just write them like this. There's your vertices. Foci. Again, you would have to decide, okay, C tells me that the foci are 4 units away, but are they 4 units left and right or up and down? For now, it's still left and right. So what would be my coordinates of my foci?
Plus or minus 4, 0.
Plus or minus 4, 0. And we've already kind of said this or implied it as we've been going. The major axis goes in which direction here? Yeah. Left, right, horizontal. So major axis is horizontal. Now, if the major axis is horizontal, obviously the minor is vertical. You don't have to write that. I think that's it. So when they ask you to discuss an ellipse, that's all the stuff they want to know. No directrix, you don't have to worry about that. But there's kind of an extra thing here. We have this major axis, so it's same amount of stuff. 4 things you got to describe.
So when you're given like one of these discussed ones, the vertex number is just whatever you have is A plus or minus 0 and then 0.
The vertex is, you have to factor in the center.
Mm-hmm.
So the center so far has always been the origin, but it's going to be A units left and right of the center, or above and below.
Yeah, that's what I was asking if it was just A.
It's going to always have something to do with A.
And then for the foci, it's C.
It'll have something to do with C, but it won't always just be C. But yep, it'll always have something to do with A and C. All right, so here's the other equation. Notice this time everything is above and below. C units below, C units above the center, foci. A units below, A units above. There's your vertices. So A and C still mean the same thing. It's just the distances now are vertical instead of horizontal. Major axis is going up and down. How would you know that? By looking at the equation. The bigger number would be under y. The smaller number is under x. So for today, it's the a and the b that can switch places. The x, the y, and the 1 don't. Tomorrow, it's not going to be the a and the b that switch places. It's going to be something different. The equations for an ellipse and what we're going to do tomorrow look almost identical. All you have to do is change one thing, and it makes it a hyperbola. All you have to do is change that plus to a minus. Which is good in a sense, because then you don't really have a whole new formula to learn, but I think it can be a little confusing because they're so similar, it's very easy to mix them up. So you want to really make sure you understand ellipses first before you throw in hyperbolas. A is still bigger than b, which is still bigger than 0. And c squared still equals a squared minus b squared. All stays the same. All you've done is switch these two. Now, so far, these tables they're in your packet. First one is on page 390. The second one is on page 392. But we're going to do an example with this, but it's not the table that I would really, or the equation that I would really recommend. The one we're going to use accounts for the center shifting left and right, or up and down. And that table is that's on page 394. Okay, so for the test on Friday, that's the table I'll have on the board for you. Okay, so let's discuss this ellipse. Okay, this one, it's not ready to discuss. What's wrong with it? Yeah? It doesn't equal 1, right? I told you today everything has to equal 1. So what would we have to do to make it equal to 1?
Divide everything.
Yep. Divide everything by 9. 9, 9. Now it equals 1. And we really want everything to have a fraction. So what would be in the bottom of x squared now?
1.
Yeah, we want to just leave that 1 there. Now we're good. Okay. Questions on that so far? Okay. Well, let's discuss it. What's the first thing we should write down about it? Yeah. We should even get that first, because if we don't know A, B, and C, we can't really describe the 4 things that we need to. So it's easier to get those first. What is A in this case? Rob?
30.
A is always the bigger number, and you take the square root of it. Yes, A is 3. B is always the smaller number, and you take the square root of it, but in this case, B is still what? 1, same as B squared. And now C squared equals A squared minus B squared. A squared is 9, B squared is 1. So C squared is 8. So what is C? Square root of 8. Okay. Now I think we're ready to describe. What's first thing I can describe, and this one's pretty easy so far. The center. Let's do that first. So your center, where is the center?
0, 0.
It's 0, 0. Now the next thing I would describe, we're going to do it in a little different order from the last one. Do the major axis next. Because that's going to set up all your other answers. Are your other answers left and right, or up and down? Which way does the major axis go in this equation? And how do you know that?
Vertical.
It goes vertical, how come?
Because the bigger numbers under the water.
Exactly. Exactly what you just said. So major axis is going to be vertical. Now what that tells me is A and C are going to be above and below. They're going to be vertical. They're not going to be left and right. So A is going to help me to describe the what? Vertices. Okay, so where are my vertices going to be? I know my center is at 0, 0, and I know A is 3. Yep.
I just have a question. For the major axis, so like the bottom numbers, I'm confused on how you got it. The major axis.
So you just look where the bigger number is, and that tells you which way it goes. If the bigger number is under Y, it goes in the Y direction.
Oh, okay.
Bigger number under X goes in the X.
And then the vertex or whatever would be plus or minus 3, 0? Or no, 0 plus or minus 3.
0 plus or minus 3, because it's above and below. Yep. So there's my vertices. And foci. Kathleen, where are my foci going to be?
0 plus or minus 8.
Yeah. Square root of 8, not a nice number if you really had to graph it, but now what you might see them do with a problem where it's square root of 8, if it's a multiple choice question, you could see something like this. Let's see. Any question on how you would get that? So just like always, they might reduce that square root. Okay, any questions on that one? Okay, so these conic sections are all kind of the same. You're all doing kind of the same type of stuff. All right, find an equation for the ellipse. Okay, but regardless of what they have you do, try to get A, B, and C first. That's kind of the stepping point to figure out everything. Right, so based on the information they've given me, anybody think they can tell me either A, B, or C? Yeah. Yep, A is 3, I agree. So A is the distance from the center to the vertex. Now, I agreed with her that A is 3, even though they didn't tell me the center. I know the center. How do I know the center? I know it's at the origin. Besides the fact it's the only type of problem we've done so far, they've given you a piece of special information there that you should know where the center is. Yeah?
Zeros are in front of us.
So the fact that these are both zeros doesn't necessarily tell us that the center is at the origin. It would tell us something about the center, but there's something else here that gives away where the center has to be. Yeah?
The plus minus.
Yeah, this plus minus. That's what tells me where the center is, because I know the center is exactly in between the two vertices, right? So if I draw my vertices, I got one at plus 3, I got one at minus 3. Well, the center has to be halfway between the two of them. So what's halfway between plus 3 and minus 3? 0, 0. Now these zeros by themselves would at least tell me that the center is somewhere on the y-axis. But that's all that those zeros would tell me, right? If I blocked these two numbers and somebody walked in right now and I said, where's the center? That's all I'm going to tell you. They could say, well, it's on the y-axis, but I can't tell you where. Any more info, right? And that's enough information. Now, technically, you could put a plus minus here too, even though they didn't. All right? But any question on? I don't know. Okay, so we know A is 3. How about one other letter we can get from that information? Yeah?
C is 2.
Yep, C is 2. Now they want the equation, so you don't really need C, you need B. But there's no way to get B without C. So we've got to figure out how to get B now. So how do I get B based on what I know?
Put it into equations. C squared equals A squared.
Yeah, put it in the equation, c squared equals a squared minus b squared. Usually these are nice numbers, so most of the time you can just pretty much do it in your head. C squared, a squared, minus b squared. So when I do that out, b is going to end up being the square root of what number? Oh, 20? 5, right? Square root of 5. You're going to get the negative 5, but then it's going to cancel with the negative in front of the b squared. Then take your square root. Don't even worry about what the square root of 5 is, because you don't really need the square root of 5. You're going to have to square it anyway when you put it in the formula. Okay, so let's write down the formula. Equation for an ellipse is always equal to what number? Always equal to 1. You always have two fractions. What's always on top of the left fraction? This never changes for an ellipse. It will for a hyperbola though. X squared always goes here, y squared always goes here. Now, we've got a and b, but we've got to figure out where to put them. Which way does the major axis go in this ellipse? How do we know? Yep.
Vertical.
Yeah, it goes vertical. How do you know?
Because the numbers are in the well.
Yeah, all the numbers are on the y, right? Here's your vertices, here's your foci. Everything's lining up this way. The points aren't lining up horizontal. They're all vertical. So this is going to go up and down, which means you want to put the bigger number under y. So what number is going to go under y?
3.
Yep. 9. Remember, what goes under x squared and y squared is always a squared and b squared. So a squared under y, b squared under x. Okay, so any questions on that equation? Okay, I'm not going to subtract 1/5 x squared and then multiply by 9 and get y by itself, but you could graph it if you wanted, and the calculator would graph it in 2 pieces. 1, 2. Oh, except it would actually make it look like an ellipse. Any questions on that? All right. So a circle is really, and this is the only thing I'm really going to say about a circle, because if you studied ellipses, they pretty much include circles. It's a special case of a circle where a and b are the same. So instead of writing 2 different numbers in each denominator, it's really like you just have the same number in each denominator. Call it a, call it b, you can call it whatever you want. Because in a circle, you know, if you pretend like, okay, that's my major axis and that's my minor axis, well, that doesn't really apply. They're the same. The major and the minor axis are, you can't tell the difference between the two. So the distance from the center to the vertex or from the center to the minor axis doesn't matter. It's the same distance. And what they usually do when they write the equation of a circle is they move, since these 2 numbers are the same, they just move it over to the other side. Now you can't really do that with, well, you could do it with the ellipse, but they don't because the numbers are usually different. But when they're the same in a circle, they put them on the other side. And does anyone have a guess what that number really is in a circle? You wouldn't call it the distance from the center to the major axis or the center to the minor axis, because there is no major or minor axis. It's just the distance. Yeah. It's just your radius. Yeah. So if you had a circle, we just say it's the distance from the center to the edge. And it's the same everywhere. It's not like it's different in different directions. So just trying to point out that an ellipse or a circle is really just a special case of an ellipse. But that's all we're going to say about circles. Any question on it? Okay. All right, so the final version of an ellipse can have the center shifted. Okay? The coordinates, or the letters that we use to describe the coordinates of the center are h, k. So you're going to see exactly the same equation you just had, except next to the x and the y, you're going to see a minus h and a minus k. If you get rid of the minus h, pretend like it was minus 0. When you get rid of the minus k, because k was 0, you get the exact equation you just had before. But now h and k aren't necessarily going to be 0. But everything else is still the same. Still equal to 1. Always put the bigger number under the letter that represents which way you want the major axis to go. So if you want your major axis horizontal, put the bigger number under x. If you want your major axis vertical, put the bigger number under y. So again, the center is h comma k. Let's see, c squared still equals a squared minus b squared. You can still use that. A is always bigger than b, which is bigger than 0, so no negatives. Just remember that in the formula, it's always minus and minus. So be careful if you get something where h or k is already negative. You're going to end up with minus and minus, which becomes a plus. So that kind of thing can happen. You know what? So we can do it without the chart. Because if you can remember that A is the distance from the center to the vertex, and C is the distance from the center to the focus, that's all you have to remember.
No, I vote chart.
Yeah, give me the chart. Chart would be good.
Yeah, I'm a very visual person.
Well, if you need the chart, it's on page 394. But I'm not going to write out, they give you all these formulas for how you can find the focus and direction. I don't even know what the formulas are. I'm just going to think of it like this. It's going to be much easier to think of this than to try to think of all the different formulas on that chart. For parabola, it's kind of hard. Parabolas are harder. This one's easier. Okay, let's look at one. All right, so find the equation of this ellipse. Okay, first step, no matter what you have to do, is find all the letters you need. So now you need A, B, and C, just like always, but you also need H and K. Okay, out of the 5 letters, are there any letters there that we can figure out pretty easily? Okay.
H and K.
Yep. What's H?
2.
Yep. And K? Done. Those 2 are done. So as far as like extra work, that's it. That was the extra work. Now we're going to do this just like we would any other problem. Find A, B, and C just like always. So Emily, what is A again? What's A?
A is going to be
Just the definition. You don't have to give me the actual answer here.
from the center to the vertex.
Center to vertex. Got it? Got it. So all I have to do is look at these 2 points and figure out how far apart they are. Now if you need the distance formula, you can, but remember, they're going to line up on a horizontal or vertical line. So what's the distance between the center and the vertex here? Yep.
3.
Yep, 3. That's 3. So you don't really need a fancy formula to figure that out. And just remember that. Okay, C, distance from the center to the focus. Well, you've got your center, you've got your focus. How far apart are the center and the focus? 1. So C is 1. And now B, they're probably never going to give you that one because you can find it with the formula. C squared equals A squared minus B squared. So C squared, C squared is 1. A squared is going to give me how much? 9 minus b squared. So what will b come out to? And technically, we don't even need b. We really need b squared. That's what you're going to put in the formula. But that works. B is the square root of b. Okay. Now, let's set up our template for the formula, for the equation as much as we can. And then we'll figure out what to plug in. Okay. One thing I always know about the equation of an ellipse is what? Yep. Always equals 1. So it always equals 1. You're always going to have two fractions. They're also always going to be squared. What letter always goes in the first numerator? Yep. We're always going to have an x. What letter in the second numerator? Y. Now, if it's at the origin, you're done. There's nothing else you have to do. But now we have to take into account that it's been shifted. H units left and right, K units up and down. Notice, X and H are always together. X and H always go together. Y and K. K is the vertical. That's your up and down. So, what should I put right in my first numerator? X minus what? Blake?
Minus 2.
Minus 2. Now be a little careful here. What's going to be your second numerator? Yep. Y plus 3. If you think, well, why isn't it y minus minus 3? Then it becomes a plus. All right, so we got that. Okay. Last thing I have to figure out is where a squared and b squared go. Well, if you're not sure, graph your focus in Vertex and see which way they line up. If you were to graph those, how would your focus and Vertex line up? Would they line up vertical or would they be horizontal? Yeah? Horizontal? Let's check. Right 3, down 3. Okay, just real quick sketch. Vertex, right 5, down 3. Point is, they're going to line up horizontal. So that means I want my major axis horizontal. So the bigger number is going to go under which letter to make it horizontal? X. Here's A, here's B. A is always bigger than B. So you're going to put 9 there. You're going to put 8 there. And that's the equation of your ellipse. Any questions on that? And you could graph that. A little bit more work because you get some extra stuff you'd have to get. You'd have to subtract a fraction, you'd have to multiply by 8, you'd still have to take the square root, but then you'd also have to subtract that 3 to move it on the other side too. So it'd be one more step to graph that on a calculator. All right, let's try to discuss this one. Now, what's wrong with that? Does that look like the equation we've been working with so far?
No.
No. All the equations we work with have parentheses and something squared. Okay. Well, let's just kind of take a step back. What if I had something like this? Let's say I had, say, x squared plus 2x plus 5. And I really wanted to write that somehow as something squared. Okay? It's almost like I wanted to factor it, but that's not going to factor nicely. Do you remember how you can figure out how to write it with parentheses? There's a name for it, yeah?
I don't know the name for it. You would make it
So you would divide the 2 in half, or you would move the 5 over to
Yep.
the other side,
Yep, very good.
and then you would divide the 2 in half,
Mm-hmm.
and then square that number.
Yes. So you divide the 2 in half, you get 1, square it, you get 1. And now you've got something on this side that would factor very nicely if you've done it correctly. That's called completing the square. Okay? So that's the whole key. When you have something that doesn't have the parentheses in it, you have to complete the square to make it so it does. And you do it exactly the way Blake just said. We did it a long time ago, but you put your constant on the other side, you take half of this number and square it. This one wasn't that interesting. Half of 2 is 1. When you square 1, you get 1. So you got to do plus 1 on the left and plus 1 on the right. Anything you add to the left, you can also add it over on the right. Right? And then from there, it'll be a normal kind of problem. But that's kind of a pain because you got to complete the square first. Right? So let's try it on this one and see what happens. Okay? I'll erase that in a second, but I'll leave it for now. Okay, first of all, when I have to complete the square, I'd rather have all the x's and y's next to each other. So I've got 4x squared minus 8x, and I've got y squared plus 4y, and I'm going to put that negative 4 on the other side. You always just take the constant and throw it on the other side for now. Now, I can complete the square on the y's. The y's are good. There's something I don't like about the x's. Does anyone know what I don't like about the x's? Something there I don't like, yeah? No, not the negative. Something else with the x's. What's the number in front of x squared? 4. You don't want that. Right? If you're completing the square, you always want this number to be what? 1. So let's make it 1. Just go like this. Okay, now it's 1. Probably should leave a little more room after the parenthesis because I didn't leave much room there to actually complete the square. Now the y's are fine. There was nothing there you had to worry about. But leave a little room after the y because you're going to complete the square there too. You have to complete the square for the x's and the y's. Now, let's do what Blake said. What's half of negative 2? Negative 1, and when you square it? 1. So that's what you're going to put there. And now let's do the same thing for the y's. Half of 4? 2 squared? 4. Now, I added some stuff on the left. I just unbalanced it. You've got to make sure you add that back on the right to keep it balanced. What did I add on the left? I know where you got 5 from, but I didn't add 5 on the left. I added more than that. How much did I really add? Yeah. 8. I added 4 there. And then I added 4 there. So I really added 8 on the left. So you got to add 8 on the right. Okay. And now, let's factor the left. That's going to factor very nice. X minus 1, x minus 1. And the y's are going to factor y plus 2, y plus 2. Now we're starting to get something that's looking like what it should. I can already see h and k. I can see the shift. But it's still not equal to what it should be. What should it always equal? 1. So just divide everything through by 4. And then you'll have it where you want it. 4, 4, 4. So that was kind of a pain. You had to complete the square first. Now we're okay. So we have x minus 1 squared. There's nothing left in the bottom. Just leave a 1. Y plus 2 squared over 4. And 4 divided by 4 gives me 1. Okay, so we're completing the square. All squared terms have a coefficient of 1. I already told you all that. If you don't know how to complete the square, you take half of the middle term and square it. What you do on the left, you got to do on the right. I already said all that. So, yeah, let's just figure out these, and then we're good. What's h in this case? Yeah. Yep. Now be careful. What's k? -2. Right? That kind of happened on the last one too. What's a? Yep. Square root of 4. What's b? Square root of 1. And c, c squared equals a squared minus b squared. So what's c? Square root of 3. Now, I've got all the important stuff. I'm not going to go through all of it, but I'll just write down a couple of them. The center is going to be h comma k, 1, -2. Now this is where Robin asked, is the vertex always A? And I had said, well, it'll have something to do with A. In this case, it'll be 2 units away from the center. We have to figure out which way. That tells me which way right there. The bigger number is under Y. It's going to be 2 units above and below. So the vertices, 2 units above the center would be, what would that be, 1, 0? And 2 units below the center would be 1, -4. Same thing with the foci, except you'd go square root of 3 units above and below. That's just going to be a messy decimal. But that's the idea with how you do it. Because you don't have to worry a ton about the completing the square. That's a little bit harder of a problem, but you should definitely be able to do one like this. Okay, we didn't have to complete the square at all here. Any question on that? If we need to practice another completing the square when we go over homework, we can do that. Because it's an algebra technique that we learn, but most people don't use it a lot. They just figure they use quadratic formula instead. So we don't practice completing the square a lot.
Is this in the packet or both?
That's in the packet. So 397 in the packet. 13 to 17, 21, 27 to 31 odd. And then I guess I could have just said 39 to 47 odd. I don't know why I wrote it that way. And then 55.